In this video, I'm going to show you a new formula that you can use whenever you know that two events are independent. In this example, a survey is given to an entire school, including students and teachers, to see whether they prefer to watch football or basketball. They concluded that the sport someone prefers and whether they are a student or a teacher are independent events. They also found that the probability of choosing a teacher is 0.23 and the probability that someone prefers football is 0.52. We need to fill in the two-way table using this information. Since we've been given values of probability, we're going to fill in the table using values of probability as well. We know that the values of probability always need to add up to a total of 1. So I'm going to put a 1 in my bottom right total box. Now let's place the information we've been given into the table. The probability of choosing a teacher is 0.23. So I'm going to go to the teacher column and down to the total and place a 0.23 in that box. We also know that the probability of choosing someone who prefers football is 0.52. So I'm going to go to the row that says football and over to the total and put a 0.52. Now we can find the probability of choosing a student by using our complement formula. We know that the probabilities always need to add up to 1. So I can take 1 minus the probability of choosing a teacher, which I know is 0.23. to get the probability of choosing a student. And 1 minus 0.23 gives me 0.77. So in the student column, down in the total box, I'll put a 0.77. I can do the same thing for finding the probability of choosing someone who prefers basketball. Since the probabilities have to add up 1, this will be 1 minus the probability of choosing someone who prefers football, which is 0.52. And 1 minus 0.52 is 0.48. So I'll put that in the total box in the row that says basketball. Now, currently I don't have enough information to fill in the remaining boxes. The only other thing they told me in the example is that these two events are independent. I'm going to show you how to use the fact that the events are independent to derive a new formula that will allow us to find the remaining probabilities for the table. So we're starting with the fact that we know these events are independent. And we already know this independence formula, which is that the probability of an event A is equal to the probability of A given B when we know that the events are independent. So I'll start by writing my independence formula. And again, the reason we're starting with this is because we've already been told that these two events, A and B, are independent. Now we're going to use the conditional formula for our next step. As you can see in the independence formula, we have the conditional statement, probability of A given B. And we know that the probability of A given B is equal to the probability of A and B divided by the probability of B using our conditional formula. So I can replace the probability of A given B with that fraction from our conditional formula since we know that they're equal. So I'll leave the probability of A on the left as it is, and then replace the probability of A given B with the probability of A and B divided by the probability of B, because we know these are equal due to our conditional formula. Now, as you remember from the previous page, we are looking to find the probability of the intersection of different events. So we want to isolate the probability of the intersection of A and B. And by isolate, I mean we want it to be by itself on that side of the equation. So to get this by itself, we need to move the probability of B in the denominator. And we can do that by multiplying by the probability of B on both sides. So on the right side, the probability of B cancels out. And on the left side, we have the probability of B times the probability of A. And on the right side, we're left with the probability of A and B, which is exactly what we wanted. Now I'm going to go back to my previous page and add this to our formula list so we can keep track of the formulas we know. Our new formula is that the probability of A and B equals the probability of A times the probability of B. But remember, we can only use this formula if the events are independent. And the reason for that is because we started with the fact that the two events we were talking about are independent, and that allowed us to create this formula. So you can only use this formula when you already know the events are independent. Since we know these events are independent, we can use this to fill in the rest of the table. So to find the next probability, the probability that someone is a teacher and they prefer football, we can multiply the probability that someone is a teacher times the probability that someone prefers football, and we already know those. The probability that someone is a teacher is 0.23 times the probability that someone prefers football is 0.52. So I can put that in my calculator, 0.23 times 0.52, that gives me 0.12. And I'm going to place that in the box that corresponds with teacher and football. Now we can do the same thing to find the probability that someone is a student and they prefer football. So I'm going to take the probability that someone is a student, which is 0.77, and multiply that times the probability that someone prefers football, which is 0.52. And I can put that in my calculator to get 0.77 times 0.52 gives me 0.40. And I'm going to put that in the box that corresponds with student and football. Now, to find the last two values, we could use that same formula again, but there's actually an easier way. If I want to find the probability that someone is a teacher and prefers basketball, I already know that the probabilities in my column under teacher need to add up to 0.23. So I can take 0.23 and subtract the probability I already have in that column, 0.12, to get the missing probability, which would be 0.11. So I'll put a 0.11 in that box. And I can do the same thing with the column that says student. I know that 0.40 and the missing value need to add up to 0.77, so I can take 0.77 minus 0.40, and that gives me 0.37. So I'll put that in the last box. And you can always check your work